I want to take a minute and expand a little bit on some of the aquatic ecosystems that we're going to see in the Yellowstone ecosystem. So first, lotic ecosystems. I'm not going to talk specifically about specific lotic ecosystems, but lotic ecosystems refer to ecosystems that are aquatic with flowing water. So rivers, streams, creeks, that kind of thing. So think low and flow, lotic and flow. Now, I want to also address lentic ecosystems, which are lake ecosystems, lake and pond ecosystems, of which we have many in the Yellowstone ecosystem. And so as we look at lakes and in terms of the different regions of the lake, along the coastline we refer to those as the littoral zones of a lake. And then the benthic zones would be along the deep bottom, and benthic dwellers live along the bottom of a lake. And then in the water column, we have the photic zone, which is a zone where light penetrates that permits photosynthesis. And then deep to that will be the aphotic zone. A means without light, photic is a reference to light. So this is a region where light penetrates, but it would not be of a sufficient intensity to permit photosynthesis. So it really depends on the depth of the lake. It depends on how much sediments are in the lake and so on, as to how far this photic zone will penetrate. So it might just be a few feet. It could literally be to the bottom of the lake if it's not a particularly deep lake, and if the water is quite clear. And then also, as I mentioned, the bottom dwellers we consider to be in the benthic zone, which would be along the bottom. If you're a fish or something like that that's swimming in the water column, freely swimming in the water column, we could consider that the pelagic zone, and so those types of fish would be pelagic fishes. And then, as I mentioned earlier, the coastal region is the littoral zone, and then the open water is considered the limnetic zone. All right. Also, when we look at lakes, there is a pattern of stratification of water and circulation of water annually within most lakes and ponds. So in winter, as you can see, what will happen is, of course, the surface is very cold, and you'll get freezing of the ice. And really all of the lakes of the ecosystem, even Lake Yellowstone, the largest of these and the deepest of these, will freeze completely. And as ice forms, as we've talked about, or we'll talk about rather, ice is actually less dense than water. Water is at its densest at about 4 degrees centigrade. And so water will sink then as it gets to about 4 degrees centigrade. And when ice forms, it's actually less dense, and ice will form at the surface. So as ice forms at the surface, air gets trapped there. That creates an insulating barrier, and then that prevents the deeper water from freezing. But we do get this stratification of a slight thermocline, so slightly warmer at the surface, colder actually deeper in the lake. Or excuse me, ice at the surface and then cold water deep to that, but it doesn't freeze. Now, in spring then, ice will melt, and then that leads to a turnover of the water. So deeper water will be brought to the surface water will circulate around. And so that helps oxygenate the deeper water, and also the deeper water has nutrients, and that'll bring that to the surface. Then in summer we get a more severe thermocline. You'll get warmer water, significantly warmer water at the top, colder water down at the bottom. And then again in autumn, as the surface water cools and sinks, that will cause upwelling of the deeper water. So the water turns over in autumn and spring and then stratifies in winter and summer. Now, as we look at lakes of the Yellowstone ecosystem, there are 3 types of lakes that we find in the Yellowstone ecosystem: oligotrophic, mesotrophic, and eutrophic. And when we were up in the ecosystem last summer, we prepared a little video that will describe oligotrophic and mesotrophic lakes to you. I'm standing in the icy cold water of String Lake in beautiful Grand Teton National Park to tell you a little bit about one of the ways in which ecologists classify lakes, and that is according to nutrient density in the water. This lake I'm standing in is an example of an oligotrophic lake. The prefix oligo means few or little, and the word trophic is reference to the amount of food, and in this case nutrients in the water. And it is, as is typical of an oligotrophic lake, this water is crystal clear. This is a typical alpine lake. Drainage is coming off of the mountains behind me, off of granitic rock, and that drainage has very few nitrates and phosphates, which are important to the algae and aquatic plants in lakes. As a result, again, this water is crystal clear. There's very little plankton in it. There's very few aquatic plants. And as a result, the resulting food web is also highly depleted. So an oligotrophic lake not only is low in nutrients then, it also is low in productivity and low in total biomass. Now the next step up from this would be a type of lake known as a mesotrophic lake. So meso is a reference to medium or intermediate. So it has a medium quality in terms of nutrient density, and here again we're talking about primarily nitrates and phosphates. And so since there are more nitrates and phosphates in the water, this then leads to more productivity, more algae, more aquatic plants, and then more organisms that can feed on those, greater biomass, greater productivity in that body of water. Now, most of the lakes in the Yellowstone ecosystem are going to be oligotrophic. A few may bleed into that mesotrophic area. What we don't really see are eutrophic lakes in the ecosystem, but eutrophic lakes would be those that have the greatest nutrient density and generally the greater biomass that goes along with that. If you've ever been to the deep south or some other areas of the country, you'll see eutrophic lakes. So they usually have a lot of vegetation, a lot of nutrients that flow into them. So that really defines a eutrophic lake. Now, one other couple of terms I want to introduce also, I'll be using these at different times throughout the course, and so I want to kind of lay that groundwork now. One is the concept of niche. Sometimes you'll hear it pronounced niche, but that is basically an organism's job in an ecosystem, sum total of what it does in an ecosystem. And then also related to that, this concept of competitive exclusion. And in competitive exclusion, this concept is that no two organisms can occupy the same niche in the same ecosystem, that one or the other will have some advantage. And this becomes significant when we have introduction of alien species into ecosystems. They will try and do oftentimes fill the niche of an existing species, and it may not completely fill that niche in the sense that other animals that previously fed on a native plant may not feed on that new plant. So anyway, but this is something that I'll be talking on throughout and touching on throughout the course. So I wanted to go ahead and lay a little bit of groundwork and introduce these terms.